welcome back. Let's do a few more problems, a few more derivatives with inverse trig. All right, so we want to find the derivative of y equals arc sine 2x plus 5. We have our formula over there, dy dx equals f prime of x over the square root of 1 minus f of x squared. Our f of x in that formula there is the 2x plus 5. The derivative of 2x plus 5 is 2, using the power rule. All right, so now we want to find the derivative of the whole equation. All right, so we're going to have 2 in the numerator, the derivative of the inside, over the square root of 1 minus 2x plus 5, the f of x, all squared. All right, now we don't want to leave it like that. All right, let's simplify that. That could be simplified. We can combine like terms, right? Make that look simpler. All right, so let's square the 2x plus 5. And so, this will generally always be simplified out. And maybe it wouldn't be just, on a multiple choice question, but generally this is simplified out. All right, so that would be 2x plus 5 times 2x plus 5. We'll simplify that, and then we will distribute the negative, right, and combine like terms. So when you're multiplying that, just if you want to be able to do it faster, it's going to be the 2x squared, the 5 squared, plus then x with a coefficient of 2 times 2 times 5. Twice 2 times 5, because it'll be 2 times 5. Or we can just expand it, right? No big deal. I'll expand it just to make sure it's clear. So dy dx equals 2 divided by the square root of 1 minus 4x squared, right, and 2x times 2x, and then 2x5 and another 2x5, we got 20x, and then 5 times 5 is 25. Let's distribute the negative and combine like terms. So dy dx equals 2 divided by the square root of 1 minus 4x squared minus 20x minus 25. We could combine the 1 and the negative 25. So our final answer, dy dx equals 2. Maybe if I move this over here. I'm writing towards the bottom of the screen, and I know at the bottom of the screen, if you pause, what the heck, that there's a black bar that kind of blocks what you're seeing. So maybe I should try to move this up a little bit. There we go. I don't know what this is. I'm sure nothing. All right, so dy dx equals 2 divided by the square root. We can combine that 1 and negative 25. So negative 4x squared minus 20x minus 24. And there we go. Our final answer. All right, let's try another one. One done. This time, we want arc secant. All right, so y equals arc secant, 3x minus 4. Find dy dx. We've got the formula there for arc secant. Dy dx equals f prime of x over the absolute value of f of x times the square root of f of x squared minus 1. And that equation, maybe I'll put it over here. F of x equals 3x minus 4. Should have known. Can't seem to make I'll put it over here and I'll move it. So f of x, so I don't have a distorted equal sign. F of x equals 3x minus 4. The derivative, of course, is just 3. And we'll just move that over there. So we have a little bit of space over here. So dy dx equals 3, right, f prime of x, divided by the absolute value of 3x minus 4 times the square root of 3x minus 4 squared minus 1. We'll expand. whoops, that was supposed to be an absolute value bar. All right, so 3 over the absolute value of 3x minus 4 times the square root of 3x minus 4 times 3x minus 4 minus 1. Right, so dy dx equals 3 divided by the absolute value of 3x minus 4 times the square root of, so we've got 3x squared, 3x times 3x would be 9x squared. We got 2 negative 4 times 3x's, so that's going to be minus 24x, and negative 4 times negative 4 plus 16, and then minus 1. And boy, this is an easy simplifying. It's as easy as subtracting 1. So dy dx equals, final answer, 3 divided by the absolute value of 3x minus 4 times the square root of 9x squared minus 24x plus 15. Done. All right? Got 2 done. Only took 6 minutes. We're cruising now. All right, let's look at another problem. And actually, I have only 4 more problems for us. All right, so here, you can add this to your notes. If f of x equals cosine 3x and f inverse of 0 equals pi 6, find the derivative of the inverse of x at x equals 0. So the point on the inverse is 0 pi 6, right? For trig functions, given radian measure, you find, let's look at the inverse here. So for inverse trig function, given the trig ratio, you find the radian measure, right? So the trig ratio is 0. The measure of the angle is pi 6. On the trig function, it's reversed, right? So a point for f of x would be pi 6, 0. For a trig function, given radian measure, you find the trig ratio. So pi 6 is the angle, the radian measure. 0 is the trig ratio. So x and y are switched between the function and the inverse. Now this is a super easy inverse to find because we know that the inverse of cosine is going to be our cosine. And we know how to take the derivative of our cosine, so no problems there. All right, so if f of x equals cosine 3x, then f inverse is going to equal, oops, need an x there, f inverse of x is going to equal our cosine of 3x. All right, so now we can take the derivative of that. Notice we have a function. We're taking our cosine of something more than just an x. So let's just call it g of x. So g of x equals 3x, our inside function there. Its derivative is just 3. No big deal. Right? So the derivative of the inverse is going to be the derivative of the inside times negative 1, so negative 3, divided by the square root of 1 minus, in this case, what we call g of x, our function there that we're taking the arccos of, 3x squared. So let's simplify that. Oops, we need our prime mark. I don't ever know where to put the prime mark when I've got, how about there? When I've got the inverse. There, that looks clear. So f inverse, the derivative of f inverse is equal to negative 3 divided by the square root of 1 minus 9x squared. All right, so now we want to evaluate that at x equals 0. That is x equals 0 for the inverse because we know we plug the ratio into the inverse function and the angle measure comes out. All right, so this is the slope. Let's find the slope of the, so when we're plugging in 0, we're finding the slope of the tangent line. So the slope of the tangent line, right, that's going to be f inverse of 0 is negative 3 divided by the square root of 1 minus 9 times 0 squared. So that's just going to be negative 3 divided by the square root of 1, and that's just negative 3. That's the slope of the tangent line at that particular point. let's write the equation of the tangent line. Now, got to be careful on this one. We get the slope by plugging into the derivative. We get the point by plugging into the original function. So if this is our, actually no, let me take that back. That's our original function, but we're taking the derivative of this one, sorry. So we're taking the derivative of this one here. All right, so when we plug our point in, we're going to use that function, right? But we don't really have to worry, do we? Because we already have our point, right? So if they didn't give us the pi 6, right, we would plug in the 0 and get the pi 6, and we'd plug into that one. All right, but that is our point for our tangent line, right? Because we're taking the derivative of the inverse, not the original function there, not f of x, but f inverse. So the equation of the tangent line here, all right? So we have the y-intercept, so that's pretty easy. So y equals negative 3x plus pi 6. There we go. Not much to that one, is it? All right, I'm going to do 3 more problems. And whoops, well, I'll do that one again. I forgot to erase that page. The only reason that's up there, I'm embarrassed to admit, I started recording, and all of a sudden I looked down, I never plugged the microphone in. So it was a silent recording. So now it's a recording with sound. So let's do this one now. All right, so we're going to find the equation of the tangent line at the given point for the 3 functions here. And only one of them is an inverse. We got a trig inverse there. We got an arctan in there. But that's okay. Good practice. All right, so we got f of x equals 7x plus sine 2x. F prime of x, derivative of 7x is just 7. For sine 2x, it would be a chain rule. We're going to take the derivative of the outside, right? So that would be cosine blop, in this case cosine 2x, times the derivative of the inside, times the 2x. Derivative of the 2x is 2, so our derivative here is 7 plus 2 cosine 2x. All right, so now we're asked to evaluate. So to find the slope of the tangent line, actually let me write that in. And actually write the point too. Slope of tangent line at 0, 0. All right, so that's going to be f prime of 0 equals 7 plus 2 cosine 2 times 0. Well, that's just 7 plus 2 cosine 0, and cosine 0, that just equals 1. So this is going to be equal to 9. We've got the y-intercept, right, 0, 0. This is a pretty easy equation to write. So here's the equation of the tangent line. Y equals 9x. There we go. We're done. Let's try the next one. I'm just going to make that a little neater. All right, so let's take the derivative. Hopefully I have enough space here. Maybe I should have. There. Here's the first one. All right, let's take the derivative. All right, so f prime of x equals derivative of x cubed is 3x squared. Derivative of 8x is 8. And derivative of cosine 3x, derivative of cosine blop is going to be negative sine blop. And then we take the derivative of the blop, the derivative of the 3x. So the derivative, f prime of x, will equal 3x squared plus 8 minus, derivative of 3x is 3, minus 3 sine 3x. All right, so that's it to finding our derivative. Let's find the slope of the tangent line. at 1, 0. Just plug in the 1. So f prime of 1, because it was just x's, is equal to 3 times 1 squared plus 8 minus 3 times sine times 3 times 1. Well, we're not going to get a very pretty number there. Equals, we're going to have to get a decimal equivalent, I suppose. 3 plus 8 minus 3 sine 3. Well, I don't know what sine 3 is. It's not a pretty number. And unfortunately, I don't have the greatest of calculators next to me. I don't even know if it's in let's make sure it's in radians. Okay. All right, so 11 minus 3 sine 3. I get this. And we'll take it to 4 decimal places. 10.5766. That would have been nicer if they made it 0, 1. All right, so that's our slope. Now we can write the equation on the tangent line. Yeah, I think 11 minus 3 sine 3 being our slope would be a little ugly, so we'll simplify to a decimal equivalent. So we have y equals 10.5766 times x minus 1. So of course that's just going to be, if we distribute there, y equals 10.5766x minus 10.5766. There we go. There's the equation of the tangent line. That's a kind of interesting one. Let's find the last one here. All right, so our derivative. This is a nice simple, excuse me. A nice simple derivative that is squared. We have a chain rule here. All right, so we have our derivative is f prime of x equals derivative of 10x is just 10. So that one's nice. And then plus, we got blop squared. So that's going to be 2 blop. All right, so 2, I'm going to write arctangent like this. Arctan times the derivative of arctan. So that's going to be equal to 10 plus, and so in the, I'll write it out and then I'll simplify 2 arctan x. The derivative of arctan x is just 1 divided by, because here our derivative of x is just 1, divided by 1 squared plus, x squared plus 1. Now it doesn't matter which way I write that, but. All right, so we can simplify that a little bit. Let's make it look nicer. F prime of x equals 10 plus 2 arctan of x divided by x squared plus 1. It's a good thing we have a little bit of space over here. All right, so there's our derivative. Now let's find the slope of the tangent line. We'll evaluate that. So we have f prime of 0 equals 10 plus 2 arctan of 0 times, or over 0 squared plus 1. All right, so essentially that's just 10 plus arctan of 0. All right, so when we are evaluating inverse trig, right, we're given the ratio. We need to find out where that ratio occurs. All right, so I don't have a whole lot of solving space, so I'm going to solve kind of short here. All right, so in other words, let me write in a different color. we're looking for where is tangent equal to 0, right? Because we plug in, so arctan, if we have arctan 0, we've got the ratio. Where does tangent have that ratio? Right? So arctangent, of course, is going to be 0 whenever the numerator is 0. That means wherever y is 0, right? So we got two places at x equals 0, right? When your angle measure is 0, right? Arctan of 0, that would be 0. The opposite side would be the y value, would be 0 over 1. Right? And when x equals pi. That's the two places where tangent x is going to equal 0. So sorry I didn't give you all the steps on that one, but we just thought about that logically since we had a pretty easy equation there. All right, so, but remember, arctan has a limited domain. So our domain for arctan is from negative pi halves, so let me squeeze that in, I guess. So the domain for arctan is negative pi halves to pi halves. So 0 is in that range there. So 0 is going to be our answer. All right, so we've got 10 plus 2 times 0 over 1. Well, that's just 0. So not too difficult. Our answer is just 10. All right, because the rest is just 0. So the equation of the tangent line, we'll squeeze it in. It's a really easy one. Is y equals 10x. And that's all there is to it. Now, if you have any trouble with either taking the derivatives of the inverse trig functions, or you had any questions on evaluating for arctan, just let me know. Otherwise, have a great day. Thanks for watching. Bye for now.